Hello everybody. We're going to talk about section 7.1, the law of sines, in this video. There are actually two sections that we're covering in chapter 7. One is the law of sines, section 7.1, and 7.2, the law of cosines. And our job here is to deal with oblique triangles. That is, triangles that aren't right triangles. What do we do with those? So that's where we begin. We have a problem called the triangle problem. And the biggest problem that we're looking at is that we have a triangle that is not a right triangle. And so, for example, our values, sine, cosine, and tangent, can't apply normally. We cannot use the Pythagorean theorem. That only applies with right triangles, triangles that contain a right angle. Since none of these are right angles, we have to find ways, if we're given certain information, find out about the rest of the triangle. And this is an important aspect of what it is that we do in applications of trigonometry. So, our objective here is we wish to solve the triangles. That is, given some information about the lengths of the sides of the angles of the vertices, find all the remaining sides and angles of the triangle. And we'll note that angles in the triangle right here, and I'm going to go ahead and I'm going to use a highlighter here for this. Angles are labeled using capital letters. Right, so our notation is going to include angles using capital letters, and for sides, we'll say that the sides are going to use the small case letters of the opposite side from the angle. So in our situation right here, angle A is opposite of side A. Angle B is opposite side B. Angle C is opposite side C. And again, large letters, capital letters for the angles, small case letters representing the sides. All right, with that notation in mind, how could we accomplish this? There's actually two ways. We use either the law of sines, which is illustrated right here that I'm pointing to, or the law of cosines. And depending on what information we're given, we can determine which of these two rules are the important rule to use. And the law of sines is the most widely applicable, so that's the one we're going to start off with. So let's think about this triangle problem. What do we have to know to use the law of sines? Well, the rule basically says this. In a non-right triangle, if we have one of the angles and the side opposite of the angle, we have enough information to set up a ratio. It says the sine of an angle divided by the length of its opposite side will equal the sine of any other angle of the triangle divided by the length of its opposite side. And so those ratios must be constant. The sine of the angle C divided by side C. The sine of the angle A divided by sine A. Those two quantities would be equal to each other. We put it in a three-way equation like this one in order to help us out. But the way we're going to deal with it, we could put it upside down as well. If we take the length of side A and divide it by the sine of its angle, it would be equal to the length of side B divided by its opposite sine of its opposite angle. And so we have to use the law of sines. We have to have certain information available to us. And so I learned it when I was going through school this way. The situations that we can use in order to solve a non-right triangle go like this. We can either have, for the law of sines, two sides and an angle not in between the sides. We call this the SSA situation. If, for example, I'm told that I have side B, side A, and angle B, then I have a side-side angle situation. I'm given two sides and an angle that is not included between the two sides. We call this side angle. Right? Another situation in which we can solve a triangle is if we have two angles and a side not in between the two angles. So if we look at this situation, let's say that we had angle A, we had angle C, and then we had side A. That is enough information because with the two angles, angle side, we call this angle side, we have enough information to build any one of these ratios. We can take the sine of side A divided by the length of side A, set that equal to the sine of angle C divided by divided by the unknown side C, and solve for that angle C. But we have to have enough information to build at least one of these situations. Well, there's one other situation that we can use right here. We're going to call this one angle side angle. Angle side angle. And the way it works is this. If we're given two angles and a side included between the two angles, we can call it. So we're going to call this angle side angle. When we want to include a side between two angles, we call that angle side angle. And in this situation, angle side angle, we might be given enough information right here that we can figure it out. Now, why would this fall in the law of sines? After all, we're given, let's say, angle A, we're given angle C, and we're given side B. It doesn't look like it's enough, right? We'd have to have angle B. Well, we can use this situation because, as you know, the angles inside any triangle, angle A plus angle B plus angle C, always must add up to 180 degrees. And that's useful for us because we could find angle B if we wanted to by taking 180 degrees and subtracting from it the other two angles to get our angle B. So we can use the angle side angle situation when it comes to the law of sines. Now that's it. These are the only situations that we have in which we use the law of sines. Now there are some other situations. If you recall, we talked a little bit before right here. I was pointing out if we wanted to use the law of cosines, that's a different situation. We would use these situations with the side angle situation, the angle side situation, or the angle side angle. Another one that would work right here with the law of cosines if we had side angle side, or if we had all three sides. That's it, right? Because in this set of rules that we'll talk about in section 7.2, we need to be able to build at least one other side or one other angle given the information right here in order to use the law of sines. So, law of cosines, we'll get into that in the next time dealing with this. But for right now, here's what we say. These are the situations that we're going to talk about. And so when we go through the examples in this video set, I'll just go through each of the different situations to show them to you, and then talk a little bit about some proofs and a couple of special situations.